so I don't forget like every time. Are we gonna have makeup days? I don't think so. School should end at the same time that it's supposed to. We only have 4 weeks left of school. And it'd be really unfair if we made you do makeup days, especially since a lot of California isn't sure if the schools are going to be reopening even in fall, like when it's going to reopen. Because if you think about it, and it's 11/10, so if you think about it, right, that this pandemic that's happening, schools are like the epicenter because there's like thousands of kids that go there every day, right? I mean, even when I was subbing, it's worse than elementary schools, right? Because all the kids there are like bags of germs. But even in high schools, it's more likely that you're going to be, passing on the virus. Okay, so we're gonna do it like this. Okay. All right, guys, we're going to get started here. So this is going to be a little bit different than the other weeks. So last week was homeostasis part 1. This is homeostasis part 2, technically. The problem is that we have already finished homeostasis, like, before break happened. And there's no, like, PowerPoint for this week. So even if there was more information to give you guys, there's nothing for me to tell you other than just to keep saying the same old thing, right? So Mr. Jonas had this cool idea. I'd never heard of this before, of like doing like an experiment. So 2 weeks ago, we were talking about enzymes, right? We were talking about protein synthesis and enzymes, and how enzymes help, get things going. They're the thing that starts chemical reactions. And you'll get more into chemical reactions when you get into chemistry. They're very important, but they're also important to, like, help us live. If this bottle falls over during the experiment, I swear to God. Okay. So we were talking about enzymes, and we thought it'd be like a cool thing to show you, like when an enzyme. Okay, I guess we'll see. We'll let Adele in. We haven't started yet. Well, we haven't started the experiment yet. We thought it'd be cool to let you see, kind of enzymes in action, how all of this works. So he recommended this, and we'll see what happens. So first things first, lab safety. I'm wearing shoes for the first time in ever. When you're home all the time, you don't really need to put on shoes. And then if you go out, you just put on like flip-flops. Also, my hair is grown out very long, and yeah, send help. Send help. Anyways, I should be wearing pants right now. It's basically summer already. I don't feel like it. I don't want it. I hope you all understand. You're all very understanding citizens of this community. So first things first, safety glasses. I don't have goggles. I have these sunglasses, so we're gonna put the sunglasses on. So now I look cool while I cause explosions to happen. My mom is very scared that I'm gonna blow up the house today. So let's hope I don't. So first things first, we're gonna be taking this hydrogen peroxide. Very hard to find nowadays because Trump told us to ingest it in order to get rid of the virus. Yes, he did. Okay, so First, take a half cup of hydrogen peroxide. We're just going to squirt it in there. Okay. Cool. So we have this half cup hydrogen peroxide. I cannot read the comments, guys. So we pour it into the bottle. Okay. Next, in order to see what's going to happen, we have the chemical reaction itself. We have to put something to like capture it. So the plan of this is hydrogen peroxide is made of H2O2, right? And if you know what water is, it's H2O. Oxygen is O2. So theoretically, after this H2O2 kind of breaks down, you're going to have water, so H2O, and oxygen. So when that reaction happens, all that's going to be coming up is like all this oxygen. We have to capture that oxygen. So what we do is we take this dish soap. We're going to put it in here. We're going to put a generous amount. I hope that's not too much. Okay. Next, we got to get a catalyst, right? Well, first we got to swirl this around a little bit. Gently swirl. Okay. You can't see who's there. Someone's getting admitted. Oh, it's Mr. Jonas. I have to admit him. All right, welcome, Mr. Jonas. We're in the middle of the experiment. Okay, so we got the H2O2. We got the dish soap. Okay. Now, we have to get our catalyst started. So we take this yeast. I went to the store to get this as well. It should be a fun time. I'm going to use it to make some bread later. Probably. Leave in the comments what bread I should make. Okay, so we put that there. I'm going to move this. And then we have some warm water here. Okay? And using this warm water, we will activate the yeast. All right? Okay? We just let that activate a little bit. Okay. So it's getting all goopy. Good. So we did 3 tablespoons of water to 1 tablespoon of yeast. Okay. Okay. So now we just add it to the bottle. And I should have thought this out better because this is a very hard thing to add. I wish I had a funnel. You don't have a funnel. We're going to see what happens though. Okay. Okay. I should have added more things, I guess. Okay. And as you can see, the chemical reaction is happening. Look at this. Look. Oh, God. I'll bring it closer to you. My students, it is using. So what I could have done was like add some color to it, I think. So what's happening? The yeast is acting as the catalyst. It's the enzyme, right? So it's got this thing called catalase that is helping the reaction along. and it's breaking down the H2O2 into H2O and oxygen, so O2. And because of the dish soap, it's catching all of that oxygen, and what it's doing with that is it's making it into bubbles.
What the fuck?
I thought it was going to be more violent of a reaction, honestly. Maybe it would have been if I had waited a little longer on the yeast. Maybe if I get like a smaller bottle. All right, guys, don't go anywhere. I'm gonna get a smaller bottle and some color. I'll be in a minute. Gonna run. Okay, so that one was definitely white. I have this other bottle now. We were going to do it very fastly again. I just want to check the comments at all. See if anyone had any questions. We're alone now. What concentration was? Oh, okay, yeah. The concentration of H2O2 is 3%. So it's the normal concentration. So normally what you find at the store is 3% concentration of H2O2. That's anything like more concentrated is a little dangerous. H2O2 is not the safest. It's an acid, right? So it's an irritant. So we're just gonna do this again. So right, we're gonna do that. But first, we're also going to add in some colors of food dye. What colors should we add, guys? While I'm digging them out, we have what looks to be red, blue, yellow, and pink, purple, pink, or two pinks, one pink. I will watch the comments now. I can get 6% at Hair Salon. Those aren't open anymore, though. They're dead. Okay, I see red. I see another red and another red. Lots of red. Okay, we're going to do red. I hope it's red, actually. There's two things that look kind of red. I think this one's red. Okay. We put red in here. We're going to put some red here. Okay. Let me put. We swirl it. And then we add it to the bottle. Okay, so this might already just work better because it's a smaller bottle than the other one. The other one is really big, right? So we add the yeast again. We add the warm water. 1, 2, 3. Stir it around, it. Okay. And then we pour it in. Okay. Again, it's not as violent a reaction. Oh God, no, I don't want to hold this while it's coming out. And now it's like, I guess that might have been pink. I'm sorry, I let you all down. But this is science. Shake it. Yeah. Good point, Chrisia. Okay. So yeah, when you add motion to it, it's going to make it react more violently because you're putting energy in it, right? So it's a good one. Does it feel warm? Yes, it does feel warm. Yeah. So it feels warm as well, right? Because when you make this reaction happen, one of the things that's also getting let off is energy. So energy is coming out of this, and pretty much all the bubbles are now gone because all the H2O2 has been reacted. So it stopped bubbling. So another thing to get more in depth with is that in chemical reactions, you have energy going off as well as these other things. So when H2O reacts, right, with the enzyme, it's letting off H2O2 reacts with the enzyme. You get H2O and oxygen, but you're also getting energy, right? So this here, this is actually really hot. So I only added warm water, but it's hotter than the warm water, right? And also when you shake it, like Chrisia suggested, you're adding more energy into it, making it happen faster. Pretty sure. Okay. So this is our science experiment for the day. This one was still going. There's some foam. If I shake it, it gets a little bit more violent, right? I'm gonna have to clean up a lot now. But I hope you enjoyed this experiment, guys. So another thing that you could do at home, maybe. I mean, you could do this at home. Just make sure you take the right precautions, right? Don't make a big mess. If you're gonna do it, I'd suggest to do it outside, like I'm doing it, because I can't do it in my room. Or I guess you could do it in like the tub. But yeah, so you could do that. Another one that's cool to see, like chemical reactions, that's just super easy. You can pick up at the store is Mentos and Diet Coke. You might have heard of it. You might have seen it on Mythbusters. That's another one. Let's see. Yes, Isaac. All right. What assignment? Will a reaction always be hot, or can there be a cool reaction? Reactions are pretty much always hot, right? Because it's giving off energy. If it was cool, then the reaction would have had to absorb all of the energy that was put into it and the heat. So I don't think there is a reaction that does that, or I don't know off the top of my head, at least, if there is. If I do it cold, is there no reaction then? Well, the yeast has to activate in warm water, but theoretically, let's say, yeah. So if there was no heat at all, it might be possible there might not be a reaction, but that also might be that might be a result of the enzyme being non-functional because it's too cold, right? If it's frozen. Okay, so assignment this week. so the assignment for this week is activity 2 in the packet. So that in the packet this week that's the summary portion, right? So I looked at it. There was a few questions, but on it, like, you guys should all know how to do it right now. I don't need these anymore. And then, yeah, so activity 2, and then let's see. What's the question you guys should answer? Like, I don't know, if you have questions from this, send that in, or tell me, what kind of experiment you'd like to see next, right? See if I can do it, because I don't know how much lecture there's actually going to be in the next 4 weeks. And I might be able to set up another kind of pseudo experiment for you guys to watch, since there's no more Bill Nye the Science Guy out anymore. Anyways. Okay, so that has been this week, guys. It's been a fun time. If we joined the Zoom, what part of the packet do we have to do, or do we have to do it? I guess my chat doesn't like auto update. Yeah, so just do activity 2 of the packet, and then send me either a question that you had from this, that, like, if you stood on, or like a kind of experiment you might like to see in the future, if you know any. And I'll be looking up some too as well. Okay, guys. So this was fun. Maybe I'll try and get like a more reactive version. I'll break into a hair salon in the middle of the night and steal some. And then, who knows? Yeah, thanks for coming, guys. This has been fun. I always look forward to Tuesdays, seeing you guys. The one that shoots up a foamy worm. I'll have to look that one up. I don't, but I'll have to look it up. Amazon, that's true. Do the experiment where my dad comes back? That sounds like a really hard one to do. No, I'm not in the business of building people. That's true. I can go to Amazon and get it. If I tinker with anything, with any more of this stuff, I might submit it to YouTube too. But yeah, so this one's gonna go up too.